Today we're going to learn how to apply some of these trig solving for side formulas that we've learned, law of sines, law of cosines. To start with this, one of the things we need to talk about is we need to talk about the idea of bearing. A lot of this stuff is used for navigation. So bearing, we ought to talk about directionality on the globe, north, east, south, west. So one of the things that we really get confused by, we've got north 38 degrees west. What does that mean? Well, that actually gives us a ray that points out from the origin, kind of like we drew with the unit circle. Now, we'll start with this. We can draw this thing. It points to the north. But it's not straight north. It's north with a tilt of 38 degrees in a westerly direction. West is to the left. So from this spot on the north, we're going to turn this way. We're going to tilt it towards the west, and we tilt that 38 degrees. So when we fill this in, it tells us one of these angles. This right here, where we move this, is 38 degrees. But it allows me to find both of these too, because I know inside this is the quadrants. So we know that these quadrants add up to 90. So what does that leave us here? That leaves us 52 on this side. So once we have one of these bearings, we can fill in different parts of these angles as we go through once we know these quadrants here, okay? Now another way you could see this, S65E, that's south 65 degrees to the east. So we would start off pointing to the south, and we would rotate 65 degrees towards the east, meaning that this line goes somewhere around in there. They don't need to be perfect, just so we get the relative overall general direction of it. But we turn from a south heading towards the east 65 degrees. So that's 65 goes in here, which means that this 25 is in here. We can find either one of those angles. Now where that comes into use, so let's go ahead and try this problem right here. So this one says a footbridge is to be built across a small lake from a gazebo to the dock. From a tree 100 yards from the gazebo, the bearing is E 24 degrees S. From the tree to the dock, the bearing is S 15 degrees E, and the bearing from the gazebo to the dock is south 33 degrees west. What is the length of the bridge? So we've got a picture down here drawn for us. There's a lake in here. We want to put a dock to this gazebo, and we want to figure out how much lumber we're going to need to build this dock. We need to figure out what the length is going to be. Now we've got another point out here. This is actually how surveying works too. And we know distances to this, because we can because it's not going over water. But if we look between these 3 points, we get 3 points, we can triangulate this, which is what we are working on. So let's actually go through, and we got to kind of fill in some of these distances, or I'm sorry, not distance, but yes, one distance and a couple of these angles, okay? Now what you need to be careful with though. So this says the bearing from a tree 100 yards from the gazebo, so that tells us this length right here. Let's fill that in before we talk about these angles. So we know that this is 100. Is east 24 degrees to the south. So from the gazebo, from the tree to the gazebo, so we're going this way. It's east 24 degrees south. That's not this angle in here. We've got to draw the line east, south, west. So what I think would be easier with this little trick that I learned as we went through, and I actually learned this from a student as we went through, it kind of made this jump out. I'm going to draw a rectangle around all this stuff, put it through all these points. Because then I can see, well, this is east, right? This is south, so on and so forth. But that east 24 degrees south, well, east is this way to start. That's what this line represents. And 24 degrees to the south is down. That 24 degrees actually falls right there. Let's try that again for this one. So a tree to the dock. So we're going tree to the dock. There's a bearing of south. So south is this way, but we're going to turn 15 degrees to the east. So south is down from our tree. We're going to turn towards the east 15 degrees. That angle is actually out here. bearing from the gazebo to the dock, so gazebo to the dock is south. South is down. But we're going to turn that 33 degrees to the west. West is that way. So 33 degrees to the west puts that angle right in here. Now, what I think makes this a little bit easier as you go through, you put this on the outside. By putting this in a rectangle here, we know that these are all 90 degrees because we drew them and that's what we want them to be. It allows me to find all of the angles in this thing. Because what makes this a little bit tough, because what is the length of the bridge? The bridge is right here. This is what we want to solve for. With what I'm given, none of those angles are inside the triangle yet. I'm not even sure how to find all of them. I can find this one, but it makes finding these a little bit tougher. Finding these right triangles on the outside makes this whole process a little bit easier. So we know that all three of these angles should add up to 90, so let's plug that through. So let's see, 24 plus 15 is what? That's 39. So if we take that away from 90, we find out that that angle right there is 51 degrees. I'm going to put that in a different color. Let's use, I don't want to use red, let's use black. So this one right here has to be 51 degrees. Oh no, use the highlighter. So this one's 51 degrees. That's an important angle because that one's inside. Now, I filled in what we were given in blue. I'm going to fill in the rest of the stuff in black so we can set this up. Because this is 90 and this outside thing's a right triangle, that's going to allow me to find this angle, and then I can use the sum of these as 180 to find in here, and I can find all the angles in this triangle and make this problem easier. So 24 and 90 is 114. So we go 180 minus 114 tells me that this angle out here needs to be 66 degrees. 66 and 33 is 99. We know all three of those add up to 180 because that's a straight line. Tells me that this angle right in here is 81 degrees. Now I can do the same thing with this outside. 33, 90, I can use that to find the angle out here. So 90 plus 33 is 123. We take that away from 180. We find out this angle down here is 57. 15 and 90, so that's 105. So that's going to tell me that this is 75. And then those three should add up to 180 because that's a straight line. So 75 and 57, and then we take away 180 minus that, and we're going to get 48 degrees in here. Now let's check our math, make sure we get everything set up. So 51 plus 81 plus 48, and lo and behold, that's 180 degrees that are inside our triangle, okay? So I'm gonna actually draw this triangle again over here with just the label of what I want to find. See if I can make that a little bit easier to see. So let's see, like this. And we'll label everything. So our tree was right here. Our gazebo's over here. Our dock is over here. This was what we wanted to solve for. And we figured out that this was 51, this was 81, and over here was 48. And we were given that this was 100 feet. Now that we filled all this in, let's look at what we're given and what we need to solve. So we want to solve for this. We know the angle opposite this now. So we're going to try to use the law of sines first. Come over here, this 100 is matched up with the angle of 48. So because I have a filled in angle side, I can use the law of sines to solve for this, which is nice because it's easier. So this tells me this is x over the sine of 51 equals 100 over the sine of 48. So we'll cross multiply and solve this stuff. So we're going to get x times the sine of 48 equals 100 times the sine of 51. So x equals 100 sine 51 divided by the sine of 48. And we'll plug that in and see what we get. So 100 sine of 51, and then we'll divide that by the sine of 48. And also, don't forget, we're plugging in degrees. Make sure your calculator or whatever you're using to find these answers, Desmos, whatever, is set in degrees, okay? So this tells me 104.6 if we round it to one place. And we know that's measured in feet because this distance was given in feet. So that's where our feet come in right in here with this 100. So that distance for our bridge needs to be about 104.6 feet long, okay? All right, let's try this second one. So this says a boat is sailing due east, parallel to the shoreline, at a speed of 20 miles per hour. At a given time, the bearing to the lighthouse is south 68 degrees east. 30 minutes later, bearing is south 52 degrees east, okay? So what we have going on here is we've got a boat that's traveling due east, this way. And it's measuring its distance to a lighthouse. I'm finding the angle to that lighthouse. So it makes this triangle because it measured it two different times. And what we're looking at here is we're going to find the distances, and we want to figure out how far is the boat at position 2, meaning right here, how far away from the lighthouse is it? If it travels straight to the lighthouse, how long will it take it to get there? Okay, so we've got our due east. We got to start figuring out some of these angles in here and everything. All right, so first off, we are given a distance. It's given to us a little bit differently than we normally would see it. 20 miles per hour, that's a rate of change. It means in every hour we travel 20 miles. Also tells us that there's 30 minutes between these two measurements. So how far do we travel in 30 minutes? 30 minutes is half an hour, so we're going to travel half that distance. So we know the boat is traveled 10 miles here. Now, to figure out some of our angles here, what we are going to do, we're going to draw our rectangle around this thing like we did on the last one and see if we can put everything in its right spot. So I'm going to put it in red so it looks a little different. We're going to go all the way to, let's go to the boat. We'll go all the way to the lighthouse. We'll make it work. Okay, so first one we're given is bearing of south 68 degrees to the east. That's our first bearing. So south is this way, and we turn that ray 68 degrees to the east. So that means that this angle right here has to be 68 degrees. And remember, because we drew this as a rectangle, we know that these angles down here are 90 as well as these up here in the corner. So we can use that to find this one inside the triangle. We know that these two right here should add up to 90. So that's going to leave me what? 22 degrees inside the triangle. So that's helpful right there. At this second spot, this one's a little bit different. So we've got to be a little careful here. The second spot, our bearing is south 52 degrees to the east. South is this way for this spot. And that 52 degrees is towards the east. So we're looking down here at south. So we know that this angle right in here is 52 degrees. But we also know that this is a right angle because that's south and that's west. So we do know that whole angle inside that part of the triangle right there. 90 plus 52 means that this is 142 degrees overall. That'll allow us to find this last angle in the triangle here, and we'll be able to use our law of sine. So let's see if we can put all this together and make the picture a little bit prettier. So I'm just going to draw the triangle like we did with the last one. So we're that way across, down to a lighthouse here, and here. That's pretty close. And things that we knew. So we figured out, let's label our stuff here. So this was position 1, this was position 2, and this was the lighthouse. So we figured out that this was 22 degrees. 90 plus 52 means that this is 142. We know that this is 10 miles. And 142 and 22 is 164. So we go 180 minus 164 here. And we find out this is 16 degrees down here. You can make that a little bit neater. So we are, and what do we want to find? Let's label that. We want to find the distance from our second position to the lighthouse. But we now know a side angle opposite. We have the 10 miles is opposite this 16 degrees down here. And that's our filled in one. And the one we want to find this x. And it is opposite the 22 degrees up here in the corner. So we can use the law of sines again. X over the sine of 22 degrees is equal to 10 over the sine of 16 degrees. We're going to cross multiply and solve that. So x times the sine of 16 equals 10 times the sine of 22. We'll divide this over, and that'll be what we can plug in our calculator to find this. So 10 times the sine of 22, and again, make sure you're in degrees. We're going to divide that by the sine of 16. I get 13.59, so let's say 13.6. So they are 13.6 miles away from the lighthouse. Hardest part of these things is setting them up. Draw pictures. I really like this rectangle around the edge idea. Helps you see the lines a little bit better. Take some practice. Make sure you put it in. Reach out to me if you need help.